Welcome to all. Now we are moving to the last problem on this topic. Determine the nodal displacement supports reactions for a 3-pinned trusses as shown in figure. Take E Young's modulus is 200 into 10 raised to 5 Newton per centimeter square. So this is a structure they given. In the structure they mention the length between these two support is 500 centimeter square, and each bar having a area of 20 centimeter square, and this is 10 centimeter square, and this point the load is acting downward 100 kilonewton, and also the length of this particular bar having a 800 centimeter, and also this bar having a inclined angle of 60 degree. Now as usual procedure, first we need to rewrite the given structure. So we'll mark it 1 2 3 nodes 1 2 3 and divided into 3 elements. Node 1 element 1 2 3. Now complete the previous problem. The main difference on this is, so they given this length but they are not given what is the height of this. Instead of that they are given degree. Therefore in order to calculate the coordinates we need to know this, then only can able to calculate. So therefore we need to calculate that length, that is, let's make a triangle. Let's drop a vertical line here, horizontal line here, and you can observe that it form like a right angle triangle. So therefore we can apply a trigonometric rule now. So we know theta here, therefore we can apply sin theta and cos theta. Suppose I need this height, you need this height means, so this is a form a triangle having this is called adjacent side, opposite side, and this hypotenuse. So therefore this we need opposite one. Opposite means according to the sin theta it is opposite by hypotenuse, therefore A become L2 into sin theta, hypotenuse is L2. Similarly cos theta means adjacent by hypotenuse, adjacent is B and hypotenuse is L2, therefore B if you want then B become L2 cos theta. So we know L2 because this is L1, it is 500 centimeter, L2 they given here 800 centimeter, and therefore substitute that value and we got A as 693 centimeter and B is 400 centimeter. Correspondingly now we need this L3. So therefore L3 we know we want means, so we can take again one more triangle, that is a bigger triangle. It is also a right angle triangle, therefore either we can apply trigonometric rule as well as Pythagoras. But if you want to apply the trigonometric rule, you don't know the theta of this. Therefore you can apply the Pythagoras rule, because I know this length, I can able to calculate this length as well as this height. Therefore according to the Pythagoras rule, L3 square is equal to this length. This length is L1 plus B whole square plus height of this will be A square. So L1 we know, B we know, A we know, therefore we can able to calculate the L3, transfer square into this side, therefore that is become 1136. Therefore we got this L3 now. Now we can able to calculate the coordinates. So let's at node 1 the corresponding coordinates are x1 y1 and it is 0 comma 0. So and here 500 comma 0, that is x2 y2, and this height x3 y3. What is the x3 y3 length? L1 plus B. What is L1? 500 plus B is 400. So therefore that is become 500 plus 400, that is 900, and y3 nothing but A is 693. Therefore we got as A3 as 900 and 693. So now one more thing you have to observe here, at node 1 and node 2 they given it is hinged. Hinged support means it can take it cannot be make a transverse movement, like x direction it can't be moved and y direction it can't be moved, but it can able to rotate like this. Therefore we consider the corresponding coordinate, what is the nodal displacement q1 q2. Q1 is the nodal displacement along x direction, q2 is the corresponding nodal displacement along y direction. These are the transverse direction, but if you give the hinge also there is no transverse displacement. Even again here q1 0, q2 0, and also the force is not acting here, therefore f1 0, f2 0. Similarly at node 2 q3 q4 and corresponding forces are F3 F4, that is also 0 0. But come to here. So here the load acting, the nodal displacement is Q5, Q6. Both are there. Even F5 corresponding nodal forces are F5 and F6. F5 is along x direction, the nodal force is not given, therefore 0. But along y direction it is given, that is F6 is 100 into 10 raised to 3 Newton, convert into Newton. But this downward, as usual, you know that downward forces we consider as negative. Now based on this input, as usual procedure, we can proceed to the next step. So this is only the very important one, different corresponding to the previous problem. This is only the different part of this problem. They given the theta, therefore we applied the trigonometric rule, and to calculate L3 we applied the Pythagoras rule. Based on that we calculate the coordinates. Now we'll move to the as usual step now. First one, you know that nodal data. There are three numbers 1, 2, 3 corresponding xy coordinates. x1, y1 are 0, 0, x2 is 500, 0, and x3 is 900 and y3 is 693. And next one is the element connectivity table. So let's write the element number, initial node, final node, element length in centimeter. Now they are given every units in centimeter, therefore everything I calculate in centimeter only, and corresponding direction of cosines. Total elements are 3, corresponding initial node and final node we are writing, and that is, you know, very familiar with that. For no element 1, the initial node is 1, final node is 2. For element 2, initial node is 2 and final node is 3, and for node element 3, initial node is 3 and final node is 1. So that is one thing. Now I directly written here because this is very familiar. In the previous problem I shown already, that's why I directly written the final values, so that you know how to calculate LE1. So LE1 is nothing but already in the problem, in this problem LE1 we know 500, that you directly substitute, and LM direction of cosines. L means, so x1, that is x2 minus x1 divided by LE1. If you do it, that x2 we know 500, x2 we know 500 minus 0 divided by 500, that is 500 by 500 become 1. Similarly m become y2 minus y1 divided by LE1, that is become 0. Similarly we calculated for element 2 and element 3 as usual procedure. Next step is element stiffness matrix, that you know very well. If there are 3 elements are there, therefore each individual stiffness matrix we need to find K1, A1, E1 by LE1 and corresponding direction of cosines. So that substitute the A1, E1 and LE1 value as well as the direction of cosines L, that is 1 and 0, and simplify this, then you will get K1 as this much, and corresponding row number and column numbers are 1, 2, 3, 4, 1, 2, 3, 4. Similarly element 2, A2, E2 by A2, E2 divided by LE2, and this is the direction of cosines, and substitute all the values, finally simplify, then K2 will get like this. So what is the corresponding rows number and column number, that you know well. For element 2 it is 3, 4 and 5, 6, that you have to write it here. Similarly K3, it is, you will get the K3 as this much after substituting the A3, E3 and LE3 and LM value. That is corresponding node numbers and column numbers are, row numbers are 5, 6, 1, 2 elements. Finally global stiffness matrix, that is adding K1, K2, K3, therefore the matrix size becomes 6 by 6. You add the corresponding K1, K2, K3 value, then you will get the global stiffness matrix as usual procedure. You add it, then you will get like this. So now global force vector, so total 6, F1, F2, F3, F4, F5, F6. So up to F5 it is 0, only F6 is 100 Newton into 10 raised to 100 into 10 raised to 3 minus Newton. Q is equal to up to Q1, Q2, Q3 up to Q6. Now finally we need to substitute in the equilibrium equation, that is KQ is equal to F. Substitute corresponding global force vector, global stiffness matrix as well as Q matrix as well as F matrix value. Now boundary condition, as usual procedure, using elimination method we are going to apply. Since here node 1 and node 2 are injured, node 1 and node 2 are injured, there is no transverse movement as I told, therefore Q1, Q2, Q3, Q4 are 0 only. Therefore eliminate corresponding nodes, rows and column. First row, first column, second row, second column, third row, third column, fourth row and fourth. That's all. Now what is the left remaining matrix is, it is 2 by 2 cross matrix, this much. Now finally calculate Q5 and Q6. So Q5 get 2.219 centimeter and Q6 is minus 1.743 centimeter. We substitute all the values in centimeter, that's why nodal displacement also will get in centimeter. And finally calculate stress for element 1, that you know that sigma 1 is E1 by LE1 minus L minus M LM Q1 Q2 Q3 Q4. You substitute corresponding values of direction courses as E1 or LE1 as well as nodal displacement. All the nodal displacements are 0, therefore finally sigma 1 also become 0. Similarly sigma 2, substitute the values. The nodal displacement is Q3 Q4 Q5 Q6. Q3 Q4 is 0. Q5 Q6 we got here, right? 2.219 centimeter as well as minus 1.743. You substitute, and finally sigma 2 is minus 9.98 into 10 raised to 3 Newton per centimeter square, that is compression. And sigma 3 as usual, so that is if you substitute the values, then you will get 12.14 into 10 raised to 3 positive, therefore it is under tension. So this completes the problem. Suppose there is a note I given. Suppose in the case if the load acting is oblique in nature, oblique means inclined, then what we need to do? So the effect in both sides, therefore we need to resolve the forces in x as well as y direction. For example, this is structure given here, load acting, you can see at an angle theta, so they will give the theta. So therefore the effect of this F will be along x direction also there, along y direction also there. Suppose here F1 F2, at node 2 F3 F4, and node 3 F5 F6. What is F5 become? Now it is F5, always you know that force resolve, horizontal we consider as cos theta and vertical we consider as sin theta. Therefore F5 become F cos theta, F6 become F sin theta. So these only the changes, rest of the steps are same. So therefore if the load is given inclined, then you have to resolve along x as well as y direction. So that is only the changes you need to incorporate. So this complete the topic analysis of trusses. So very easiest one. The problem is it is almost is a repeated one. So 12 marks or 10 to 12 marks they will give. So this complete the total module 2 topics. Thank you.